What's going on, y'all? Here we go. We're gonna check out these little majiggers here. We're gonna go ahead and be solving for a specific variable, and we're gonna use what we know about inverse operations to do that right here. Okay, this is a really quick review, right? So if you just kind of say, hey, what's the opposite of addition? Well, that would be subtraction, right? And the opposite of subtraction would be addition. So we have that kind of cycle of inverse operation there. The opposite of multiplication would be division, and the opposite of division would be multiplication, right? And what about taking this square? If you're squaring a number, the opposite of squaring would be take the square root, and the opposite of taking the square root would be taking it square. And so what the purpose of this right here, when you do the inverse operation, what it does is it cancels it out to only being one here. So check it out, okay? This is gonna be kind of cool here. So if I'm trying to solve for r, okay, right here, if I'm trying to solve for r, I have z equals the square root of r over t. So I need to actually get rid of the square root. And so we come right here, the opposite of the square root is squaring. And see what happens is when I square both sides, squaring a square root, those are opposite operations, which means they cancel each other out. So look, I'm only left with r over t now. See, pretty cool, right? And then over here I have z squared. I'm still trying to solve for r, so if I have my t on the bottom, which basically, if you think about it, what operation is the t doing right now? Well, the t is being divided, right? It's r divided by t, so the opposite of division is multiplication. So we're going to multiply both sides by t. We're going to multiply both sides by t, okay? And again, we always do the same operation to both sides to keep it equal, right? Because we have an equivalency on the left and on the right side. So what is the purpose of multiplying? Well, because those are going to cancel out. Just like the square and the square root cancel out. So I'm left with just r, and then I have t z squared. Okay, and you don't have to put like parentheses or a dot here because when they're next to each other in mathematics, that implies that they're being multiplied. All right, so that would be that guy right there. Cool beans. Moving over here, we're gonna go ahead and solve for and so let's go ahead and do that. So I want to solve for a, and the way that we're going to do that is we have to first again get rid of our square root right here, right? So we just learned that the opposite of square rooting is squaring. So I'm going to square both sides. Cool beans there. So I'm left with x squared on this side. And again, that just canceled those out, okay? So now we're going to have a y plus z over a. Okay, so I want to get a, so this one may be a little bit more creative thinking here, because we don't necessarily want to get rid of the y plus z, because that means we're going to have 1 over a if we were to do something like that. So what I want to do is I'm going to actually move a over here. And the way that we do that, again, is right now a is being divided, so I'm going to multiply both by a, okay? You say, what? Why? I'm going to show you why though, because you're going to see here that we can solve for a easily. So those are going to cancel out. Cool beans. So I have a times x squared is equal to y plus z. And this now is kind of cool because now a is being multiplied here, right? So if I want to get rid of x squared, okay, x squared is being multiplied right now, right? X squared times a. Then the opposite of multiplying is dividing. Okay, so those cross out, and now I have my a, which is what I wanted, right here. That's why I wanted my a, is y plus z all over x squared. And there we go. We solve for our a, and we solve for our